is Julia, I'm from Brazil, and I'm currently a student of PPCR 2020 Principles and Practice of Clinical Research. And finally guys, I made it. Let's do a review of Module 2, Basics of Statistics, and the bibliography I'm using is our course book, Critical Thinking in Clinical Research. Look guys, I'm a student, I'm not a TA, okay? So critical thinking while watching these videos. So guys, in this first video, I'm gonna start talking about basics of statistics, and I'm gonna focus on types of data.
I decided to divide my videos into smaller parts so it doesn't get any boring, or at least more boring. But okay, let's go.
So first, we need to know two things before deciding what statistical tests we are going to use in our study design or trial. So what are those things? Independent variable and outcome. What do we mean by knowing this? So how are we going to measure these things, and how are we going to say that this works or not? So we need to know exactly how we're going to measure these two things. And further after the trial, we're going to analyze these two variables, the independent variable and dependent variable, remember. Well, but before starting, what is a statistical test? Well, it is a test which aims to test a hypothesis. Right, it's pretty easy actually. So a statistical test has the ability to reject a null hypothesis when it is false. So basically it is the power to reject a null hypothesis, okay? Well, so remember that null hypothesis is like the two interventions, maybe intervention and control or whatever. The null hypothesis states that these two interventions don't have any different effect in the groups, right? So the effect of both of interventions are the same. And the alternative hypothesis states right the opposite. So the intervention does have one intervention has a better or worse effect than the other, right? So we can actually state that our alternative hypothesis can be two-tailed or two-sided, which this statement doesn't have any side, any direction. So the one intervention, for example, drug A, can be better or worse than drug B, while one-sided or one-tailed alternative hypothesis state the direction. It has to be or better, or worse than the other drug B, for example. Okay. Well, so we already know what a statistical test is, but first, to apply a statistical test, we need to know exactly what are we dealing with. So this is our data set. But we need to know our data set first before trying to create hypotheses on something that we don't know, that doesn't make any sense at all, right? So in order for us to know what exactly we are dealing with, we need to apply something that describes the data. So that would be a descriptive statistics. This kind of statistic aims to describe and characterize the data set we're dealing with. So it involves central tendency measures, mean, mode, and median, and how spread out is the data, how the data is spread around its central, right? So mode, mean, and median. So this could be like interquartile range or standard deviation and so on. Okay, so this is our descriptive statistics. Then we already know what are we dealing with, so then we can go and state a hypothesis, and then we can apply inferential statistics. So it is really related to the hypothesis. It aims to prove, to accept or reject a hypothesis. Okay, well, so now we are ready to go to our variables here. We have two huge kinds of variables: the qualitative data and quantitative data. Okay, so
I must confess that I took a while to understand all this quantitative and qualitative, because they can really overlap into each other a bit, but it can. So, well, but let's see if I can make you understand.
Well, so first we have qualitative data. the name already says a bit what is the aim of qualitative data. It aims to describe a data, right? So characterize, so categorize. So we can also say, for example, we have here nominal variables or nominal data. We can also say that this is, we can also call it categorical data because it gives names to categories, right? So it can be divided into dichotomous variables when, for example, sex, we can say that biological sex can be female and male, right? And polynomials when we have more than two categories, so gender, for example. And well, these nominal variables, despite the name, can be represented by numbers, but these numbers cannot be measured. They do not represent the number itself. It is just a representation of the name.
For example, female, I can say it's a 0 in my data set, while males I'll represent as 1. So it will be dichotomous variables, right? But also represented by numbers.
So I'm not interested in the difference between 0 and 1. It is just a representation of the name, okay? Then we go to ordinal categories, ordinal variables or ordinal data. What is a ordinal variable? Well, it can be ordered, but the magnitude of the data really doesn't exist. Sometimes we barely know, and if we know, one interval between for example,
I'm hungry, and I can say that I'm very hungry, I'm more or less hungry, and I'm not hungry at all. So can I say that the difference between very hungry and more or less hungry is the same as more or less and not hungry at all? I cannot. I wouldn't say so.
So that magnitude actually doesn't exist, and that is not our interest, right? So the focus here is only the order of the data. So I cannot say that I'm more or less hungry, then I'm very hungry, then I'm not at all hungry. Okay, so the order really exists. Well, then we can go to our quantitative data. Quantitative, really quantitative. It quantifies our data, okay? So we have two kinds here. First one, discrete data, also called count data. Why? Because we can count. Why we can count? Because it accepts only whole numbers, only integers. Okay? Well, so here, differently from the ordinal data, order matters and magnitude matters. So the spacing between one number and the other matters. And I can say that the spacing between, for example, number of birds in city A and number of birds in city B. I cannot have like one bird and a half, right? So I'm focused only on whole numbers, right? But the difference between, I don't know, 27 birds and 29 birds, it is the same as, I don't know, 30 and 31. Oops. 32. So I have two birds, like a difference of 2 birds here and a difference of 2 birds here, right? So the magnitude matters. Then we can go to continuous data. Well, continuous data is the same thing as discrete, except it is not restricted to whole numbers. It can accept decimals and fractional numbers. So for example,
height. I can say that I have, for example, 170 centimeters. It is my height. But if I have a really precise measurement equipment, maybe I can say that I have like 170 and I don't know, 8 centimeters. So this accepts like fractional numbers, okay?
Okay guys, until now, no challenges at all, right? Okay, but here I am to confuse you a bit. Okay, so let's go back to the definition of nominal or categorical data. Well, so categorical data refers to a limited, possibly small data, which can be numbered, like females 0 and males 1, remember? So that is the definition of categorical data. But we can also say that ordinal can be represented by numbers. It accepts a limited number of categories, and is possibly small. And we can go to discrete data, and we can also say that it accepts numbers, a possibly small number of numbers. So, I can say that categorical data can encompass, not all, but can encompass some ordinal and discrete categories as well. But okay guys, so you can only ignore this last detail and stick with this main definitions here. That is all fine. Okay, so that is it guys, types of data done.